Hello to all of you. This is Dr. Dhaval Maheta, and let's discuss today how to analyze Likert scale data in SPSS. After collecting the data, you must have data in this format where you must have taken the response of each statement on 1 to 5 scale, where 1 is strongly agree, 2 is agree, 3 is neither, 4 is disagree, 5 is strongly disagree. Or it can be 1 strongly disagree, 2 disagree, neither, 4 agree, 5 strongly agree. Now, how to analyze this? The first thing which you can do is you can generate the frequencies of these statements. The statements which we have asked is I have little experience of computers. The first question. The second question is all computers hate me. Computers are only useful for playing games. Computers are out to get me. Computers have mind of their own and deliberately go wrong whenever I use them. I weep openly at the mention of central tendency. If I am good at statistics, my friends will think I am nerd. My friends are better at statistics than me. Statistics makes me cry. I wake up under my duvet thinking that I am trapped under the normal distribution. Now, depending upon your research, you may also have these statements which you may have captured on the Likert scale. Some of the demographic variables which you must have captured is gender, male, female, and occupation is salaried, self-employed, and professionals. The first thing which you can do is you can go in analyze descriptives and activate the frequencies. Now transfer all the statements. I'll only transfer one statement at present. So click on charts, activate the bar chart, activate the percentages, continue. Click on format, make sure organize output by variables is on, continue, click OK, and you have got the result. I'll simply copy this result in the Word file so that I can interpret these things very easily. So this and this part has been copied to in Word file. So always report the descriptive statistics first. So what you will write is this figure. Out of 257 respondents, 10.5%, this one, 10.5% strongly agree. What is the statement? I have little experience of computer. 52% agree. 28.6% are neutral. 7.3% disagree. And 1.6% strongly disagree. On the statement that I have little experience of computer. You can repeat this interpretation for all the statements. Now we will proceed further. What we can do else? Now these 5 statements represent the fear of computers, and these 5 statements represent the fear of statistics. I'll generate a new variable with the help of these 5 statements. How can I do this? I'll go in transform, compute variable, activate all from here, and I'll activate mean. Double click on it. Now transfer the statements. 1, make sure that the comma is at appropriate location. Q2, comma, Q3, comma, Q4, comma, Q5, comma, and I'll give the new name to this target variable. Say for example, it is computer. Click on type and label, and here I'll write down fear of computer. Continue. Click OK. You can see here the new variable is calculated based on the mean of these 5 statements 1, 2, 3, 4, and 5. Now let us calculate the mean of other 5. Where will I go? I'll go in and transform, compute variable, press the reset button. Again, I will activate mean from here. Now I'll transfer the remaining statements. Q6, Q7, Q8, Q9, and Q10. This time, the fear is of statistics. Type and label. I'll give the name fear of statistics. Continue. Click OK. The new variable which is generated is fear of statistics. Now, before running any test, it is necessary that we check the normality of this new variable. So for this purpose, we will go and analyze, descriptive statistics, explore. I'll transfer computer in the dependent list. I'll activate the plots and make sure normality plots with test is on. Continue. Click OK. I've got the results. I'll simply copy these results in the Word file. What will be my interpretation? Let's see. My null hypothesis in this case is, let me write down null hypothesis. Distribution is normal. And the alternative hypothesis is distribution is not normal. I'll request all my viewers to kindly refer my previous videos to understand the flow of this lecture series. You see the p-value here. This p-value of Shapiro-Wilcoxon test. We will write the interpretation as the p-value of Shapiro-Wilcoxon test is 0.00, which is less than 5% of level of significance, we reject null hypothesis, which means that distribution is not normal. So we will use non-parametric test. If this p-value was more than 0.05, we could have definitely used a parametric test. Now, if you don't get the normal distribution, there are some methods, or rather we can say there are some remedial measures by which you can get the normality. 1. Increase the sample size. 2. Remove the outliers. And 3rd, transform the data. Transform the data we had already discussed in my video of the normality testing. We will proceed from here. Suppose we assume that the data is normally distributed. Our assumption, first assumption is data is normally distributed. Then which test we can use, and then we will talk about if the data is not normally distributed, which test we can use. Okay, let's proceed further. When our data is normally distributed, so I'll go in analyze, compare means, independent sample t-test. I'll transfer computer in the test variable and gender into the grouping variable. Basically, I want to see that the figure of computer, is it equal in male or female, or it's different. Define the groups. The code which I have used in gender is 1 for male and 2 for female. Continue. Click OK. And I have got the results. I have simply copied these results in the Word file. How will I write in my dissertation, paper, or thesis? My first assumption is that data is normally distributed. We assume, or rather you have carried out the normal distribution test and you have got the normality, and on that basis we are running this t-test. Okay, males are having more fear of computers in comparison to females. I'll convert this into the statistical hypothesis. There is no significant difference in fear of computers according to the gender. So this one, the alternative is there is significant difference in fear of computers according to the gender. You can also write null as mu1 is equal to mu2. Fear of computers is equal in male and female. Alternative, this is not equal. I will have to change this. Now, you see the p-value of this test. This p-value. The first thing which you should see, this are variance is equal. If variances are equal, then you will interpret from the first row, and if the variances are not equal, you reinterpret from the second row. I'll request all my viewers to kindly refer video number 19, in which I have discussed the independent sample t-test. Okay, what will be my interpretation? As the p-value of the independent sample t-test is 0.390, which you can see in SIG value, which is more than 5% level of significance. We fail to reject null hypothesis, which means that the fear of computer is equal in male and female. Now, this is the hypothetical situation. This one. We have not got the p-value less than 0.05, but how to write the interpretation on that? So I'm just assuming if your p-value was less than 5%, how will you write? In case if p-value was less than 5% level of significance, null hypothesis will be rejected, which means that there is a significant difference in fear of computer according to the gender. Now what? So the next thing is you will pick up the mean from here. And say, for example, you got the mean as you got the mean 1.411 here for male and 3.425 for female. The mean of male is 1.411 and mean of female is 3.425. As Likert scale, as the data has been captured on Likert scale, where 1 is strongly agree, 2 is agree, 3 is neutral, 4 is disagree, 5 is strongly disagree. How did I get this? You go in variable view and you can see from here 1 strongly agree, 2 agree, 3 neither, 4 disagree, 5 strongly disagree. Okay. So if mean is towards the lower side, then the opinion is towards the agreement sign. See, 1 is strongly agree and 2 is agree. So if male mean or female mean is towards the lower side, it means that they are agreeing more. Here you can see the male mean is 1.411, which is less than 3, and female is 3.4255, which is more than 3. So males agree more on fear of computers in comparison to females. Now, what is the next thing which I can do? Again, my assumption remains same, that the data is normally distributed. Let us go back. Here we have done the comparison according to the male and female, but we have also captured the occupation. 1 salaried, 2 self-employed, 3 professional. Now, is the fear of computer affected by your occupation or not? Let us see. So I'll go and analyze, compare means, one-way ANOVA, and I will transfer computer, and occupation will be in the factor. Click on post hoc, activate the turkeys test, continue. Options, means plot should be on, descriptive should be on, homogeneity of variance test should be on. Continue. I request all my viewers to refer video number 32 to understand the flow of this lecture series. Click OK. So these are the descriptives. First thing which you should see is a test of homogeneity of variance. I have copied this and this in the Word file for the interpretation. Let us see. What is my research hypothesis? The research hypothesis is salaried respondents have more fear of computers in comparison to professional. I'll convert this research hypothesis into the statistical hypothesis. There is no significant difference in fear of computers according to the occupation. Alternative, there is a significant difference in fear of computers in at least one pair of occupation. It can be possible because three groups are there: self-employed, salaried, and professionals. So a difference, or rather fear of computers, can exist between at least one pair of occupation. In some books, you can also write the null is also written as mu1 is equal to mu2 is equal to mu3, or fear of computers is equal in all the three groups. Alternative, it's not equal. Or you can also write mu1 minus mu2, that is a mean of first group minus mean of second group, is not equal to 0. Mean of first group minus mean of third group is not equal to 0. Mean of second group minus mean of third group. The first test which appears is the homogeneity of variance. All variances are equal. This is our hypothesis. You can run ANOVA only if the variances of three groups are equal. You will have to see the SIG value here. Needless to say that if your variances are not equal, then you will not use ANOVA. You will use Wells test. I again repeat, if the variances are not equal, you will use Wells test instead of ANOVA. So my interpretation is, as a p-value of the homogeneity of the variance test is 0.406, which is more than 5% level of significance, we fail to reject null hypothesis, so we can run ANOVA. Quite good. Let's proceed further. Now we have got the result of ANOVA. I have simply copied the result from the SPSS output. Again, you will have to see this value. As a p-value of f-test is 0.796, which is more than 5% level of significance, we fail to reject null hypothesis, which means that the fear of computer is not significantly different according to the occupation. Or in other words, fear of computer is equal in all groups. This is our interpretation. Now in case, if your p-value, this value, just again the assumption, if it was less than 0.05, what will be your interpretation? So if p-value was less than 5% level of significance, we reject null hypothesis, means that fear of computer is significantly different according to the occupation. Now in this scenario, we will further proceed for the post hoc test, which is a Tucky's test. So I'll simply copy the results of Tucky's test here, this one. And let us do the interpretation. You will again have to see the p-value of this. If the p-value is more than 0.05, the difference between the two pair is not significant. And if it is less than 0.05, the difference is significant. How will I write this? As a p-value of all occupation, salaried compared with self-employed, its p-value is less than 0.05, which is less than 5% level of significance, which means that the fear of computer is significantly different in salaried and self-employed. Now, who is having more fear? So that thing I'll get it from the descriptives. I'll copy the descriptives here where the mean will be there. So this is copied. I have definitely changed the figures to make you understand that how to write the interpretation. So salaried is 1.4170, self-employed is 3.4258, and professional is 3.4120. Now the mean of salaried is 1.4170, self-employed is 3.4258, and professional is 3.4120. So as Likert scale, which we have used, is this. So if mean is towards lower side, it means that opinion is towards the agreement side. Salaried respondents agree more on fear of computers because its mean is 1.41 and they are towards the agreement side, while self-employed and professionals are having a score above 3, which is a disagreement. So what will I interpret? The salaried respondents agree more on fear of computers in comparison to self-employed and professionals. Now, what is the next thing which I can do is, if our normality test indicated that your data is not normally distributed, then what to do? Then in this scenario, again, we'll go back, analyze, and we will use non-parametric test. Make sure one thing, that before running non-parametric test, if there is a possibility of increasing the sample size and to achieve the normality, kindly do it. Second, if you, by removing the outliers, if you can achieve the normality, then kindly do it. The third thing is, by transforming the data, if you achieve the normality, then also you can, if you achieve the normality, you will be in the position to run the parametric test. If all these three remedial measures don't work, you will go for non-parametric test. Here also, I'll go in non-parametric test, legacy dialogues. I will activate two independent samples. The same thing, that is the computers, I'll transfer it here, and my grouping variable will be gender. I'll transfer here, define groups 1 and 2. Now this test, parametric test runs on means and non-parametric test runs on medians. And the test type is mannwhitneyu test. Click OK. So I'll simply copy these results in the Word file. This too. I'll copy it here. What will be my null hypothesis here? The null is so my research hypothesis is males have more fear of computers in comparison to females. Null hypothesis for Mann-Whitney test is two populations are identical. Alternatively, two populations are not identical. Again, I will have to see the p-value here. You can see here the p-value, this one, this value. What will be my interpretation? As a p-value of Mann-Whitney test is 0.001, which is less than 5% level of significance. So we reject null hypothesis, which means that populations are not identical. The output indicates the result with the correction for ties and z-score was significant. The mean rank of male is 127.43 and that of female is 1300.76. I got this figure from here. This one here and here. So as Likert scale is 1 is strongly agree, 2 is agree, 3 is neutral, 4 is disagree. So if mean rank is towards the lower side, it means that the opinion is towards the agreement side. This means that males agree more on fear of computers in comparison to females because the score is lower of males. Now here we have compared two groups. Which test to use when we are having more than two groups? Again, we will go in SPSS, analyze, non-parametric test, legacy dialogues, and K independent samples. Again, I'll transfer computer in test variable list and occupation in grouping variable. Define range 1, 2, 3. 3 occupations we have captured. Continue. Test type is kruskalwallis H. Click OK. We got the mean rank and test statistics. I have again copied this result in Word file for the interpretation. What will be my research hypothesis? Selected respondents have more fear of computers in comparison to population. My null will be population medians are equal. Alternatively, population medians are not equal. You can see the mean rank is computed and the test statistics is also there, where I'll see the p-value. I have deliberately changed the p-value so that you can understand how to write the interpretation. As the p-value of kruskalwallis H test is 0.00, which is less than 5% level of significance, we reject null hypothesis, which means that the population medians are not equal. The output indicates the result with the correction of ties and z-score for significance. As the mean rank of, now you see the mean rank of salaried 1274, self-employed 1300, professionals 1283. So as the mean rank of salaried is 1274, self-employed is 1300, and mean rank of professionals is 1283.59. And we have captured the data on Likert scale. That is 1 is strongly agree, 2 is agree, 3 is neutral, 4 is disagree, 5 is strongly disagree. So if mean rank is towards the lower side, it means that the opinion is towards the agreement side. This means that salaried agree more on fear of computers in comparison to self-employed and professionals. Now, what is the next thing which you can do? We are having the mean score of the computer and the mean score of the statistics, which is based on the first 5 statements its mean is this computer, and the next 5 statement, its mean is statistics. Now, we want to calculate the correlation between the computer and statistics, or in other words, is fear of computer and fear of statistics correlated with each other or not, provided our assumption is that the data is normally distributed. So for this purpose, I'll go and analyze, correlate, and bivariate. I'll transfer computer and statistics. Click OK. Make sure Pearson is on. Click OK. And I have got the result. So I'll simply copy this result in the Word file, which is here. What will be my null in this scenario? There is no relationship between fear of computers and fear of statistics. Alternative, there is a relation between fear of computer and fear of statistics. Now I'll see the p-value, which is this one. Fear of statistics, you see the p-value from here. Both are mirror image. See, this part, if I talk about this part and this part, they both are mirror image of each other. The interpretation can be done from either of them. So the p-value is less than 0.05 and the Pearson correlation is 0.636, which is, as it is 2 star, it is quite significant. Now, how will I write the interpretation? As the p-value of the Pearson correlation is 0.00, which is less than 5% level of significance, we reject null hypothesis, which means that the fear of computers and fear of statistics are correlated with each other. This means that it is quite likely possible that a person having a fear of computer may be having a fear of statistics. As the Pearson correlation is 0.636, we can say that the fear of computer is moderately correlated with the fear of statistics. So this is a way you can analyze the Likert scale data in SPSS. For more videos on SPSS, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please don't forget to press the like button and also see the playlist in which I have already uploaded many videos of SPSS.